Good morning, students. In this maths class, we are going to learn chapter 8 vector algebra from page number 60 onwards. So, in this exercise, we are going to find out the unit vector, then direction cosines, direction ratios, also collinear, and how to prove that the vectors following vectors are right-angled triangle. Okay. We have already learnt that unit vector we will denote it as cap. So a cap is equal to a vector by modulus a vector. A vector by modulus a vector. This we have learned from the previous exercise. And now a resolution of two vectors. So let I cap and j cap be the unit vectors along the positive x-axis, and the y-axis have the initial point at the origin O. Then OP will be the position vector, and OP vector can be written in the form x into I cap plus y into j cap. Say we have taken that x-axis and y-axis. Just take any point P on the first quadrant, let the value be x comma y. So we know that OL equal to x and this LP will be equal to y. Now if I find it out, the OP vector is equal to OL vector plus LP vector. See OL, the value of OL is x, and the direction along this x-axis is I cap, unit vector I cap, and LP, the value of LP is y, and the direction is j cap. And now for 3 dimension, that OP vector equal to x into I cap plus y into j cap and plus z into k p. Now to find out the modulus of OP vector, see modulus of OP vector is very simple, square root of x square plus y square plus z square. X square plus y square plus z square. See, from this it is easy for us to understand. This is a right-angled triangle. In a right-angled triangle, we know the square of the hypotenuse is equal to sum of the square of other two sides. So this OP will be equal to this OL square plus LP square, that is x square plus y square. So OP will be equal to root of x square plus y square. Similar here, modulus of OP vector equal to square root of coefficient of I cap the whole square plus coefficient of j cap the whole square plus coefficient of k cap the whole square. The next part, to find out direction cosines of a vector. How to find it out? Say for R vector, we have taken R vector equal to xi cap and yj cap plus zk cap. The direction cosines are cos alpha, cos beta and cos gamma. We will say the angles alpha, beta and gamma as direction angles. Now this cos alpha, what is cos alpha? Cos alpha is equal to alpha, the angle with x-axis, beta, the angle with y-axis, and gamma, the angle with z-axis. Now this is x by r, y by r and z by r. That is cos alpha equal to x by r, cos beta equal to y by r and cos gamma equal to z by r, where r is nothing but that is modulus of r vector, that is root of x square plus y square plus z square. Now sum of the results using this. See, the first one is sum of the squares of the direction cosines is 1, that is cos square alpha plus cos square beta plus cos square gamma is equal to 1. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. And the second one is sin square alpha. If it is for cos, the value is 1, and if it is for sin, the value is equal to 2. Sin square alpha plus sin square beta plus sin square gamma equal to 2. And any vector can be written as cos alpha into I cap plus cos beta into j cap plus cos gamma into k cap. So in page number 64 and 65, this results are given. Before going to do some problems, we wanted to know how to find out collinear, or when we can say the two vectors as parallel vectors. See? For parallel, AB vector equal to some constant t into BC vector, or we can take any constant, lambda or s or m, any alphabet, or some A vector equal to t into B vector. Say the same value for collinear. For collinear, same A vector is equal to some lambda into B vector. So now we can do some problems how to find out the direction ratios and direction cosines. Example 8.5. Find the direction ratios and direction cosines of the following vectors. Find the direction ratios and direction cosines of the following vectors. See, the first subdivision or the first question is 3i cap plus 4j cap minus 6k cap. So, the direction ratios and direction cosines they have asked. See, actually, the direction ratios of this is, it's nothing but x comma y comma z. So, before going to do the sum, we will take this question as r vector. So, I am taking, let r vector is equal to 3i cap plus 4j cap minus 6k cap. Now, modulus r vector, it's needed for us to write direction cosines. So, we know that as root of x square plus y square plus z square. That is root of x square, coefficient of I cap 3 square plus coefficient of j cap 4 square plus coefficient of k cap minus 6 the whole square. So, that is root of 3 square 9 plus 4 square 4 into 4 16 plus minus 6 into minus 6 is 36. Okay, now add this all values. This is 25 plus 36, 61. So, we have got that modulus r vector equal to 61, or the value of r is equal to 61. So, first I can write that direction ratios. Direction ratios is x comma y comma z. Actually, that is our coefficients 3 comma 4 comma minus 6. The next we can write direction cosines. Say direction cosines is, know that x by r comma y by r comma z by r, that is 3 by root 61 comma 4 by root 61 comma minus 6 by root 61. So, direction ratios x comma y comma z equal to the coefficients 3 comma 4 comma minus 6, and direction cosines x by r comma y by r comma z by r, that is 3 by root 61 comma 4 by root 61 comma minus 6 by root 61. So, and here one more subdivision is asked, that is the second subdivision. 3i cap minus 4k cap. So, listen here, the value of k cap is not, j cap is not given. So, we have to consider it as 0. So, this also I am taking. Let r vector is equal to 3 I cap plus 0 j cap minus 4 k cap. Okay, same way we can find it out what is modulus or vector. That is root of coefficient of I cap 3 square plus j cap, that is 0 square, plus that is minus 4 the whole square. So that is root of 9 plus 0 plus minus 4 into minus 4 is plus 16. So we are getting that is root 9 plus 16 is 25. So this is a perfect square number. So we will be getting the answer as root 25 is 5. So now we can able to write what is direction ratios. See, direction ratio is x comma y comma z. So 3 comma 0 comma minus 4. Now the second thing is direction cosines. Direction cosines x by r. So 3 by 5. Next 0 by 5 and minus 4 by 5. So do you all understand till this? Okay, now first we wanted to do one more problem related to unit vector. How to find it out, the unit vector. Now we will do that. Example 8.4. See, find the unit vector along the direction of the vector 5 I cap minus 3 j cap plus 4 k cap. So for this we need to find it out, the unit vector. The first we learned that today is the first part is how to find out the unit vector. That is a cap is equal to mod a vector divided by modulus a vector. So first we can write that what is a vector. We will take it, since no name is given, we will take it as a vector. A vector is equal to 5 I cap minus 3 j cap plus 4 k cap. Okay, now we have taken it. Now we will find it out, or we will write the formula first. Unit vector a cap is equal to a vector by modulus a vector. If it is b vector, if we have taken it as b vector, our unit vector will be b cap equal to b vector by modulus b vector. Okay, now a vector we know, it is enough to find it out what is modulus a vector, or even we can write in the formula itself. See, we will substitute the value of a vector 5 I cap minus 3 j cap plus 4 k cap divided by modulus a vector, that is square root of x square plus y square plus z square, that is coefficient of I cap the whole square plus coefficient of j cap the whole square plus coefficient of k cap the whole square. So 5 square plus minus 3 the whole square plus 4 square. So 5 I cap minus 3 j cap plus 4 k cap divided by root of 25 plus 9 plus 4 square is 16. So 5 I cap minus 3 j cap plus 4 k cap divided by root 25 plus 9, 34, and it is root 50. Is that clear how to find it out, the unit vector? Unit vector a cap is equal to a vector by modulus a vector. The same way, how to find it out, direction ratios and direction cosines also we have learned today. Direction ratio is x comma y comma z, that is coefficient of I cap comma coefficient of j cap and coefficient of k cap. The same way, direction cosines is x by the modulus of the given vector. x by r comma y by r comma z by r. So we have learned this two today. So we will move to the next sum that also related to our direction cosines and direction ratios. This is example 8.6. Page number 65. Say that 5 subdivisions are asked. First subdivision is find the direction cosines of the vector whose direction ratios are 2, 3 and minus 6. So it's given direction ratios. Say direction ratios is given 2, 3 and minus 6. We are supposed to find it out the direction cosines. So direction ratios, what is the direction ratios actually? X, Y and Z. So they have given X, Y, Z is 2, 3 and minus 6. Now it's easy for us to find it out, direction cosines. Actually direction cosines we know that is x by r comma y by r comma z by r, where what is actually r? R is the modulus value, that is root of x square plus y square plus z square. So it's easy for us now. X by r, that is 2 by root of 2 square plus 3 square plus minus 6 the whole square, comma y by r 3 by root of 2 square plus 3 square plus minus 6 the whole square, and z by r, that is minus 6 by root of 2 square plus 3 square plus minus 6 the whole square. So that is 2 by root of 2 square, 2 into 2 4 plus 3 square 9 plus minus 6 the whole square is 36. The same way this is 3 by root of 4 plus 9 plus 36. Here minus 6 by root of 4 plus 9 plus 36. So 2 by root of 36 plus 4, 40 plus 9, 49, and 3 by 49, root 49, and minus 6 by root 49. So actually this is 2 by 49 is a perfect square number, so root 49. 7 into 7 is 49. So we will be getting root 49 equal to 7. And this is 3 by 7. And the next one is minus 6 by 7. So in example 8.5, one vector is given and they asked what is direction ratios and direction cosines. Here in this problem direction ratios is given and they have asked the direction cosines. Both, do you all understand how to find it out? Okay. Now the next second part is, can a vector have direction angles? (30°, 45° and 60°. So, can a vector have direction angles? We have learned the direction angles is alpha, beta and gamma. So, here the value is given. We have to check it, can a vector, whether a vector can have these as the angles. So, we learned two results. One result is cos alpha, cos square alpha plus cos square beta plus cos square gamma will be equal to 1. And the second result is sin square alpha plus sin square beta plus sin square gamma equal to 1. So, we can check, substitute these angles in any one of the results and find it out. So, if we use it in cos alpha, so let me take it, alpha equal to 30° and beta equal to 45° and gamma is equal to 60°. We will check using that cos square alpha plus cos square beta plus cos square gamma is equal to, this is cos 30 degree the whole square plus cos 45 degree the whole square plus cos 60 degree the whole square. So this is cos 30 degree. What's the value for cos 30 degree? Cos 30 degree, we know the value is root 3 divided by 2. Then cos 45 degree, the value is 1 by root 2. And cos 60 degree, 1 by 2. Okay, we will substitute all these values. Cos 30 degree, root 3 by 2, the whole square. Then cos 45 degree, 1 by root 2, the whole square. Plus cos 60 degree is 1 by 2, the whole square. Shall we check it? See, root 3, the whole square is 3. Divided by 2 square is 4. Then plus 1 by root 2, the whole square is 2. Again plus this is 1 by 4. Here the denominators are different. So just we will take LCM. The LCM is 4. Here 4, so 3. Here only 2 is there, but here in this denominator it is 4. So we all know that 2 into 2 is 4. Since the denominator is multiplied by 2, the numerator also we have to multiply by 2. So 1 into 2 is 2. Now here already 4 is there, so we can write it as 1. We all know that this is 6 divided by 4. Sure, we are not going to get the answer equal to 1. So we can write this is not equal to 1. Therefore, the given angles cannot be the direction angles of a vector. Therefore, they are not the direction angles. So if they have given the angles, we may able to check it. How? Whether the angles will form the direction ratios or not. And the third subdivision in this example is find the direction cosines of AB vector. Find the direction cosines of AB vector, where they have given capital A is 2, 3, 1 and capital B is 3, minus 1, 2. So A point and B is given. We are supposed to find it out, the direction cosines of AB vector. If we wanted to find it out, the direction cosines of AB vector, first we need what is AB vector. In order to find out AB vector, I need what is OA vector and what is OB vector. So using this we are going to write what is OA vector. OA vector equal to, this is x, y, z. X, y, z. So we can able to write it as 2 into I cap plus 3 into j cap plus 1 into k cap. 1 into k cap is k cap. The same way we can write what is OB vector. That is 3 into I cap minus j cap plus 2 into k cap. Okay, now we have written what is OA vector and what is OB vector. Now we can find it out what is AB vector. AB vector is, we know the formula to find it out, that is OB vector minus OA vector. OB vector minus OA vector. Okay, substitute the values. 3 I cap minus j cap plus 2 k cap minus 2 I cap plus 3 j cap plus k cap. Okay, so that is 3 I cap minus j cap plus 2 k cap. Just give the minus inside. Minus 2 I cap minus 3 j cap and minus k cap. Okay, now we can able to find it out. 3 I cap minus 2 I cap is 1 I cap minus j cap minus 3 j cap. Both minus, we will add and put the negative symbol, that is minus 4 j cap. 2k cap minus 1k cap is plus k cap. Okay, now I have got it model AB vector. So, what is modulus AB vector from this? That is root of 1 square plus minus 4 the whole square plus 1 square. We know that x square plus y square plus z square. That is coefficient of I cap the square plus coefficient of j cap square plus coefficient of k cap square. So that is root of 1 plus 16 plus 1. That is root 18. Now it's easy for us to find it out. Direction cosines. Direction cosines. We knew it x by r, comma y by r, comma z by r. That is x by r. Coefficient of I cap 1 by root 18. Y coefficient of j cap, that is minus 4 by root 18, and k cap z by r, that is coefficient of k cap 1 by root 18. Is that clear? Here direction ratios was not asked. If the direction ratios are asked, we know that is 1 comma minus 4 and again 1. 1 comma minus 4 comma 1. Is that clear? I hope all you might have understood this. Then two more subdivisions there. We will do it. Subdivision 4. Find the direction cosines of the line joining 2, 3, 1 and 3, minus 1, 2. See, same values as it is given in the third subdivision. 2, 3, 1 and minus 3, 1, 2. See, here they did not mention A and B. Simply they have given, without naming they have given, and they have asked us to find out the direction cosines of the line joining. So, here, since it is as AB vector, we took OB vector minus OA vector. That is 3, minus 1, 2, minus 2, 3 and 1. Suppose, if we take this as OB and this as OA, then our value will be different. The symbol will change. Plus will become minus and minus will become plus. So, opposite direction. So, here one set direction cosines, that's simple, 1 by root 18 comma minus 4 by root 18 comma 1 by root 18. The another set of direction cosines is just, we will get the symbol change, that is minus 1 by root 18 comma 4 by root 18 comma again minus 1 by root 18. So no need to do it again, since the same values like subdivision 3. Now the fifth part is the direction ratios of the vector is given. Direction ratio is given and the magnitude is given. Its magnitude is 5, and find the vector. We should find it out, the vector. See, subdivision 5, direction ratios is given, that is 2, 3, 6. Magnitude is equal to 5. These all given part, direction ratios and magnitude. They have asked us to find out the vector. How to find it out, the vector? See, first we will find it out, the unit vector. Since the direction ratios is given, unit vector we can find it out. In order to find out unit vector, we need the direction cosines. When the direction ratios are given, we know how to find it out, the direction cosines. Direction cosines is x by root of x square plus y square plus z square, comma y by root of x square plus y square plus z square, comma z by root of x square plus y square plus z square. So all this denominator is the same, so we can find it out separately. That is root of x square plus y square plus z square, that is 2 square plus 3 square plus 6 square, root 4 plus 9 plus 36. 36 plus 4, 40, that is root 49. We know that it is a square number, so we can find it out at the value, that is root 49 equal to 7. Therefore, direction cosines is 2 by 7, comma 3 by 7, comma 6 by 7. Now we can write the unit vector. Unit vector is equal to 2 by 7 into I cap plus 3 by 7 into j cap plus 6 by 7 into k cap. Unit vector we know that is a vector by modulus a vector. So these are the values of that vector and this is the modulus value. So it is easy for us to write, that is 2 by 7 into I cap plus 3 by 7 into j cap plus 6 by 7 into k cap. So we have found out the unit vector. Now the required vector, because they have given the magnitude is given, so we have to find it out, that is 5. The required vector is 5 into unit vector. 5 into unit vector is 2 by 7 into I cap plus 3 by 7 into j cap plus 6 by 7 into k cap. 5 by, since the denominator is common, we can take it out. 5 by 7 into 2 I cap plus 3 j cap plus 6 k cap. Okay, so we have learned how to find out the unit vector and how to find out the direction ratios, direction cosines. And if the angle is given, we know to check whether the given angles is some vector or not. All this we have learnt in today's class. So related to that, we have some exercise problems. You can just do and check it. See, in exercise 8.2, the first problem is verify whether the following ratios are direction ratios of subvector or not. We know that cos square alpha plus cos square beta plus cos square gamma equal to 1. Can take it cos alpha equal to 1 by 5 and cos beta equal to 3 by 5 and cos gamma equal to 4 by 5. In place of giving the angles, they have given the values directly. So you can check it with that. And the second one is find the direction cosines of the vector whose direction ratios are. We have did using this in example. So third sum, find the direction cosines and direction ratios of the following vector. So first three sums, please do check it, and if there is any doubt, you can ask. Thank you, students. We can see the next section in the next class. Thank you.